Hello, good evening, everyone.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Hi, Ankit. Good evening.
Yeah, good evening.
Good evening, sir.
So good evening, Nilama. How are you?
I'm good, sir. I'm good.
Good evening, sir.
Good evening, Ankit. How are you?
Yeah, I'm good.
What time is it there?
It's around close to 7 p.m., 10 minutes away. Yeah,
Okay,
it's just 2.5 hour difference.
that's not bad.
Yeah.
So in the US, we generally have that time.
Mm-hmm.
Sir, we will start sharp at 4:30. And today we are having closure from 7 so that we can close the event at 7:37. Ankit, you can also join at 7 for a short closure.
Yeah, sure, ma'am. Yeah,
Sure.
I will be happy. Yeah.
So good evening, everyone. We'll start at 4:30 sharp, so others may join. First of all, this is our last day. Thank you so much for your active participation. I was looking at the response sheet of all the part with which we shared with all the participants. Maybe we can discuss that at the 7 o'clock after Reddy's lecture as a part of closure. So thank you so much with this introductory words. I don't want to waste time, so I welcome Dr. Ankit Garg, who kindly agreed to give the second talk today. So, Dr. Ankit, over to you.
Okay. Thank you, Professor Nilima. I think today is the last day of this great workshop organized by IIT Indore, and I hope you all have gone through previous sessions and have learned quite a lot. So today, for this one of the last sessions, I picked a topic which is related to field monitoring, some of the experiences that we got in the field monitoring. It's not that we have an intention when we were doing this monitoring to study some of the effects, but when we were doing monitoring, we found that there are some phenomena that took place and that have an impact on our geotechnical properties. So today I will give a brief idea about how soil suction, which is also is related to water content in a soil uh, in near vegetation in an urban landscape. So it's basically a campus, university campus. So where we attempted or try to monitor soil suction for to understand how vegetation can influence it. And the reason, one of the main aim behind it is that we have a intention to promote use of vegetation for slope engineering or for green infrastructure. So for doing that, we need to also quantify how vegetation can impact soil suction, which is one of the main stress state variable in unsaturated soil mechanics. And while doing that, we found that when we go for nature in the field, we cannot ignore certain phenomena that can take place. So one was the shading effect, which was coming from nearby buildings, so they could give a shading to trees. And the other thing which we noticed surprisingly, fortunately or unfortunately, I would say, was termite infestation, which happened on one of the trees that we were monitoring. So I will show you during the presentation. And before that, let's understand that when we try to analyze a water flow in soil, vegetation, atmosphere continuum, so there are several processes that are taking place together, like the water infiltration in the soil, which could happen from the surface due to rainfall, and one is subsurface flow. Then you have evaporation from the ground, which is happening all the time. Irrespective you have sun or not, the evaporation will take place due to humidity gradient. And then you have transpiration from the tree, which takes place due to the root water uptake by the tree. And I think this continuum that the water flow takes place in this. When we analyze our soil properties in this particular system, we need to understand that field presentation. We will focus more on the vegetation parameters like canopy, leaf area index, riparian index, and also meteorological parameters that govern, you can say, the water transfer between soil and atmosphere, and also between plant and atmosphere. So, although we I'm presenting the effects from termite or wedge shading. But when we started this monitoring, we didn't have any intention that we will encounter these issues. So it is also one of the, you can say, takeaway message that especially for young scholars, like when you go to the field or when you do any field monitoring, it is very recommended that you should keep your mind open to also observe some of the phenomena that may be not directly related to geotechnical or in our field, because that could somehow, I mean, directly or indirectly could affect our results. So this was one of the phenomena which actually took place in the middle of our monitoring period. And you can see that there's a tree being cut down, I mean, which is due to the termite infestation. So if something happened to the tree, you can imagine that there is a significant, change in the water balance that could take place between the soil and atmosphere, especially near that region, okay? Near the place where the tree is located. So this is from a more fundamental point of view that, um, and also it was coincidentally that the tree that we were monitoring um, for last 1 year, it got infested by termites, which we found out very late. And we found that this has significant impact on soil suction. And since soil suction is one of the main stress state variable in unsaturated soil mechanics, it could further, we know that it could also influence our stability of infrastructure. But although this monitoring takes place in an urban landscape, but when we think about its implication for the green slope engineering, where vegetation, we plan to introduce vegetation as a component. We have to think about the long-term maintenance also, that during the green slope engineering, that we need to identify trees timely, which got infested, and we need to take appropriate action. So coming to termites, so termites are similar to what we see in kind of an ants, but there are different type of termites. Okay, not all termites eat trees. Okay? And termites also, they need food. Okay, for them tree is more like a food, okay, which they need to grow. And some termites, they have sponge-like fungus, okay, which kind of they are constructed to chew wood, okay, and which can cause breakdown of lignin. So you can see slowly when you have a termite infesting a tree, you can, I mean, visually, if you see this um, tree stem, you can visualize how termites could influence uh, the tree. So these termites are something that we encounter during our monitoring. So the objective was to establish a monitoring plan to analyze soil properties near the tree in an urban landscape, and which includes soil suction, and also understand it with respect to vegetation characteristics and meteorological factors. And this monitoring took place in Macau, which is very closely, which is very close to Hong Kong. And Macau is, just to give you an idea, I'm not sure many of you have heard, but Macau has been quite popular for gambling, or I would say it's considered kind of another Las Vegas in Asia. And Macau actually also have hosted many, Indian film ceremony awards before. And it's a beautiful city. I mean, those who wants to visit, there are many tourists going there. And for Indians, we don't need actually even visa for 1 month to visit Macau. So you can directly go with your passport and stay in Macau for up to 1 month. Yeah. So Macau and Hong Kong, they're kind of separated by sea, but you can transit between Macau and Hong Kong by a ferry, which is quite convenient. So this monitoring that we did for the tree, it was done in the Macau University campus. So if you look at the map, on the left side is the Macau University campus, and on the right side you see that there is a kind of a campus landscape. So where we have marked different trees. Tree 1 is located close to the building, which was intentionally. Tree 2 was located somewhere in the middle. Tree 3 was located more close to the, there was a small river which was flowing through. And you can see there are parking road, there's lane, a sidewalk, there's grass. And these pictures were taken using a UAV. And for measuring soil properties, we use soil water potential sensors. We call it soil suction sensor. Now, this sensor can measure suction more reliably in the higher range, but they are not very accurate in the low range. So for measuring the low range suction, like especially below, you can say 50 kilopascal, more reliably, we use jet fill tensiometer. But jet fill tensiometer can usually, you can use it during mostly rainy days or suction when suction is low. But this jet fill tensiometer cannot give you a more reliable suction beyond 50 kPa or 60 kPa, because after that the cavitation starts. And then you have water content sensor. And on the right side you have meteorological parameters. Now, one thing for young scholars is when we plan any instrumentation in the field, I think it's very important that we need to have an idea, first of all, what kind of range of soil suction we expect or water content we expect, at least some range that we expect in the field in different seasons and also at different depth in the soil. Because depending on that, we will plan our instrument and then place an order for purchase. And many a times what happens is if we don't have a proper idea of like of what expectation we have in the field, at least I would say not like exact expectation, but some expectation through literature or through simple theory. Okay. So you can then plan about instrumentation and place an order. And also we should be careful that some of this instrumentation you need to calibrate in the lab before we operate in the field, because the data that we get from the field sometimes is not easy to understand if we don't do proper calibration in the lab. And we use with vegetation parameter, we also measure stromatal conductance here. And at the same time, we use UAV, which was used to capture leaf tree canopy. Okay, so this UAV we capture from similar height at similar time, almost once in a month, for measuring the leaf canopy. And this tree canopy was measured or estimated using image analysis after that. So you can set actually longitude and latitudes in your mobile, so that anytime when you go and take picture using UAV every month, you can use the same coordinates, and from the same place we can take pictures to measure the tree canopy. And to plan this, we draw a simple cross section. And if you see on the T1 tree, you have a T2 and T3. So one of the main focus was T2, the one in the center. So that was the main focus. For T1 and T3, we use simple comparison. First is to understand because the groundwater table is relatively high. So we wanted to understand how T3, which is closely related, which is close to the river, how the suctions are there. And also at T1, because T1 is much closer to the building, where you could have shading effect. And we don't expect T1 tree to have much sunlight, okay, and which could impact transpiration. So we expect some differences between T1, T2, and T3 based on the presence of water in the building. And for that we focus mainly on T2, but T1, T3 we just use for comparison. So for T2, you see that on the depth of 0.2 meter, we installed the water potential sensor, which is what we call MPS sensor. And this MPS sensor is mainly to measure suction in very high range. We're talking about a range of more than, up to even 10 to the power 5 kilopascal as per the supplier. But if we calibrate in the lab, I think the suction, beyond 3000 kPa is not highly reliable. There could be increased errors, and also there's difficulty in calibration in the lab. Although the manufacturer says that you can measure suction beyond very high range. Then at the deeper depths, so shallow depth, we expect suction to be higher because of evaporation effect, and also root water uptake effect will be much higher at shallow depth. So that's why we installed a high range suction measurement probe at the shallow depth. But for the deeper depths, we installed jet field tangiometer because we also have previous field measurements that we did in Hong Kong. So there we found that, I mean, at this depth, the suction may not be high. It's not likely to be high. So for depth of 0.6 meter, you see that we only installed jet field tangiometer mainly. And sometimes, some places we also installed MPS sensor to just see if there is still a presence of higher suction. So this is something we plan instrumentation, and then we also same time collected rainfall, use UAV or UAV drone to capture images regularly. As I said, we need to understand the canopy area, which also we can understand, I mean, a simplified leaf area per tree. Because with seasons, we know that with season, the leaf area may change. Like in the summer, you expect leaves to be growing. Especially for semi-deciduous trees, in the winter they like to shed leaves. Okay? So we plan to carry this image analysis through drone, and we also measure radiation energy. Now, radiant energy is very important because if we understand from the theory, I mean, from photosynthesis point of view, it's actually the light energy which induce photosynthesis and stimulate, because it gives energy to open the stoma of a plant, which releases water. At the same time, it captures carbon dioxide to prepare food. We call it glucose. So radiant energy is very important. So we capture this radiant energy, I mean, for T2, near T2, at different distances below and away from canopy. And also we did for T1 and T3. So now for T1, you can appreciate that because there's a shading effect from the building, we don't expect much energy there. However, even for T2, there was some interesting phenomena that we found, is that I mean, with the change in the angle of the sun from day to evening, there is also significant change in the energy. It's not just day to evening, but also from the season. So like in summer and winter, your angle of the sun changes. So you will find that the radiant energy during summer and during winter is quite different, not only due to the season itself, but also the angle of the sun. And this is something that we found in the field during our monitoring. So B is during the monitoring that we found, not in the beginning. But this was the right side. C is the picture that actually taken after the tree was cut by the campus authorities. So in Macau, they have a strict campus regulations that such trees, they have to be cut. So once we collected the data and we finished the monitoring, the campus authorities, they cut the tree, and they didn't like give permission to continue monitoring till they plant another tree. So this was done, but luckily we collected the data during this entire program, and we managed to have sufficient understanding with respect to tree characteristics. So we were lucky that we had this prior planning of understanding the vegetation, leaf parameters, stomatal conductance, even before this termite infestation happened. This was because of our previous research work that we did, that where we found in the lab that the leaf area is quite important, and canopy area, which intercepts energy. So coming to the meteorological parameters, we analyzed from 7 October 2016 to 1st September 2017. So you can see, I mean, the temperature of Macau is quite similar, or the climate is quite similar to a coastal tropical climate. It's close to maybe Calcutta than Calcutta or Odisha, and also less humid. But it's a typical subtropical climate. If you have been to Malaysia, it's quite similar, I would say, not so different. But it's less humid, I would say, than Kolkata or Odisha. So in terms of climate, it's quite subtropical, and it's a coastal area. So the air temperature, you can see this the air temperature, and meaning it's not like very extreme temperatures in summer or winter. I mean, maybe you will find in many other regions, but Macau is more subtropical climate, like Hong Kong or Kuala Lumpur. And humidity, you can see this that it varies. I mean, it's quite high. Generally, you see it's around maybe 90% most of the times, but it drops also to around 50% in some time in between. And you have precipitation. You see, we measure rainfall. So these are total rainfall depth that is given. I mean, if you see the dots around, and it was during after this rainstorm that we found that the data that we are getting from the field, not immediately after, but sometimes after this 14 June, that the field data that we were getting in terms of suction, in terms of canopy area was even, I mean, even in terms of vegetation parameters was very different compared to before. And this is actually, we have started to suspect that something happened after this rainfall season. And we call it photosynthetic flux. So you can see that, I mean, we did at different points. So if you see this point A, B, C, D, they are referred to at different distances from the tree, T2. Okay. So distance means if now I think we all know when you sit under a tree, you will feel more cool, right? Little bit, not very hot, because of the shading effects from the tree. So that's the intention we have. So the point A lies under the canopy, point B lies a little bit away from canopy or between the canopy and open area. C and D are more in the open area. So you can see that point D have higher radiant energy, the one with square symbols. I'm explaining the graph, the bottom right, and point B and point C are close to each other, and point A, which is under the tree, have low radiant energy. So this radiant energy quantification, it gives us confirmation about the location also, that the radiant energy which is received by different points close to the tree. Now this is important because um, when we are quantifying suction at different depths and distances from the tree, we need to think about what evaporation taking place, because radiant energy also affects evaporation. There is a energy or heat flux. If you calculate do the energy balance equation calculation, you will find that the heat flux is also one of the radiant energy is also one of the important factors. So this is parameters which I already explained, like the left side. On the right side is uh, parameters which we compared between three trees. Okay, there are P1F, then you have T3E, and then you have T2. Okay, point E, point F. Now this is also very interesting, and this is point A. Yeah. So if you compare these three, you will find that point E, which is away from the tree, right, which is close to the river, away from the buildings, also receive higher radiant energy, which we expect because there is no obstruction. But point A receives quite low, and point F receives the lowest one, which is point F is the one which is close to the buildings. Okay, which the point F is the one which is close to the tree building, this building. So we expected this, and we got this. Okay, but one thing you'll notice that there are some points when these differences become quite negligible. Okay, you see, it could be possible during the evening or night, when there's no radiant energy. your differences are less, but also there are times when your solar elevation angle changes. So this solar elevation angle, we did not quantify ourselves, but we rather took it from the meteorological station, because for this solar elevation angle, we don't expect it to be different, at different points in the same city. It's technically, it's a solar elevation angle, which could be quite similar for a wider region. So we took it from a Hong Kong meteorological station. So we found that the solar elevation angle increases with the change in the season, like from the winter to summer, and which also causes the change in the intensity and the radiant energy. Okay, so during the winter, you have your radiant energy is minimum and intensity is because of the change in the solar elevation angle, and is maximum during the summer. So this is very important, because there's a reason also the differences between these points you will not expect much during the winter compared to the summer is because of the solar elevation angle. Okay, so I mean, for young scholars, my suggestion is when you analyze something in the field, we have to go to very in-depth understanding, and specifically for geoenvironmental problems or any basic violence, if you're thinking about in the soil, you have to consider the interaction with the atmosphere, as simple as it. And when we consider atmosphere, we have to consider the climate impact. Okay. So depending on your purpose, okay, on your objective, you may have to consider different aspects. And for some things, if even if you don't have the data which you are measuring yourself, you can think of obtaining from the meteorological station, which is there in almost every city they have. So it will, or nearby cities, to give you at least some idea or basis for your explanation. Okay, and this is you can say a kind of image analysis that we did um, for a tree. Okay, this I have shown one image only in this presentation, and this is an image analysis that you can do using it's a free program. We call it ImageJ software. You can download it from the internet. It's freely available, and the good thing about this software is that you can they have good tutorials also to carry out this analysis. Okay. They have very good tutorials, and it's a free program. And you can do image analysis to capture a two-dimensional, I would say, a simplified leaf area. I'm not talking about three-dimensional, which is almost very difficult to do for a tree, which is quite big and practically maybe very difficult. So it's a two-dimensional area that we try to capture for different trees at different months. Okay. And we use ImageJ program, which is a free program available, public program for analyzing. So we capture this canopy area, okay, we call it, and also we capture the canopy diameter. And when we compare this between these months, like 15, around from January to September, we found that around the month of June, okay, there has been a decline, quite sharp decline in the canopy area. But similarly, you have canopy, but for other trees like T3, if you see from T3, there is not a big decline. Okay, so this is something we found for the T2, tree, not for is reducing. The leaves are dying. Okay. And these trees have been planted long time before. So just to give you idea, this campus was actually constructed maybe in 2009, 2010. So during that time, these trees were planted, and they have been growing them. I mean, since then, quite easily. I would say in a favorable condition. But we expect due to the heavy rainfall that happened not for one day, but it happened over a period of time, that might have caused this termite infestation. And so there was a typhoon also in Macau in 23rd August 2017, which could be possible that since there is huge amount of moisture that might have accumulated in these trees, so this tree might have got affected. We suspect it. Okay, we are not sure about it, but we hypothesize. So we quantified leaf area like canopy diameter for T2 and T3, and we found a significant reduction like for the leaf area index if you see for T2 and the canopy diameter. Okay, so stomatal conductance similarly. I mean, we know that stomatal conductance, okay, just to give you an idea, I mentioned in the last presentation, it's the ease with which your water is released from the stomata of a leaf to atmosphere. So higher stomatal conductance implies your root water uptake is high, and your plant is quite healthy. Relatively, he feels healthy. I mean, it feels healthy to give away the water to atmosphere. But if your stomatal conductance is low, it means your plant don't want to give away water to atmosphere. It also means that your plant either might be feeling some stress, have some, water stress means like the similarly when we say we have a financial issue, similarly they have plant also plant the most important finance is water. So there could be water issue, there could be sunlight issue. Okay? So at the night time, the stomatal conductance is lower because they don't want to retain water. They don't want to lose water because they cannot have light energy to prepare food. So they want to keep the water. Or during the dry season, when the season is very dry, the water is relatively less in the soil. The plant, they don't want to give away water to atmosphere easily. So in that time, during the stressful time, at night or maybe in the drying period, the stomatal conductance is likely to be lower. Okay? So that's why we have this, up and down fluctuations always taking place. So mainly it's affected by, as I said, soil water content. It's also affected by the light, day and night. And also it can be affected by other parameters like humidity or seasonal effect. And from this is stage 1 means when the plant was relatively healthy. But in the stage 2, you see the stomatal conductance values are very high. We are talking about 200. Now suddenly, from this month, the stomatal conductance value dropped down to almost 10 times lower. Okay. Now this is stomatal conductance is basically the health of a leaf. Okay. Now such a low value of stomatal conductance we did not expect in a tree T2 in the second stage, that is after the infestation. Now this could be because due to this infestation, the plant's leaf was feeling stress, okay? And they don't want to give away the water easily. Okay? Similarly, it's just like when human beings. I'm just saying that when we have any sickness or something, we also like to eat less food, okay? Eat less, drink less water. Similarly, plants also adjust their metabolic functions when they feel stress. Okay, so termite is more like a sickness, okay, or more like a disease that happened because of this termite infesting a tree. So they also changes their behavior. So we quantified also because we measure water content and suction. So we quantified unsaturated soil water characteristic curve for this particular soil. Okay, so I'm not going to say it's just a fitting we did with different models. I think these are very common models that we use for fitting purposes. Okay. Now coming to the main result. Okay. So if we look at this point A, B, C, D, and on the bottom left, if you see, so we quantify the results into two different parts. Okay, for ease of understanding. Although during the monitoring we didn't have this planning before that we will do it in this way, but after our understanding of results, analysis of results, so to present it in a more simple way, we quantified into two different stages. One is before termite infestation and then after termite infestation. So before infestation, you see that this is on the left side is a soil suction, and the x-axis is date. So you see this point A, B, C, D. So just see the maximum and the minimum, two extreme curves. So point A, you can see it can go, the sections can go pretty high, up to 500 kilopascal, and for point C or point D, especially point C, the sections could go very low. So the point which is closer to the tree, higher suction means the water uptake by the tree and also the evaporation together may be higher. Okay? Should be higher as compared to point B at C and D. Okay? But interestingly, point D also have higher, although it's very much away from the tree, it's only in the grass, have also higher suction. So compared to point C. Now this could be because when, this is something we call tree grass competition. So the grass which is present very close to the tree, they are not very healthy because, there's a competition between tree and grass. You will often see, if you go to the field, the grass near the tree is not growing well. Okay? But when you go away from the tree, the grass is growing well. It's because near the tree takes more water, so the grass do not get enough water. So grass tends to die near the tree. But away from the tree, your grass is more healthy. So there is also tree grass competition which is taking place. It's well documented in literature. We also have a paper in Catina journal in 2017 where we actually quantify tree grass competition for different seasons. So if you look at this point C, which we don't expect it to be, lower than point D, it was primarily because we found that the tree grass competition, if you have a grass very close to the tree, is not good because that grass will not grow well. Okay. So this is simultaneously one more factor which is affecting the result. And then if you look at the after termite infestation, you can see, even if you just compare to the scale, there's a significant drop downs of suction at all levels. Okay? So if it was only one level or two level, we could also suspect there is issue with the instrumentation. We initially thought from a geotechnical point of view that maybe all the instruments are not working well, or maybe one instrument is not working well, which was very difficult to understand. We even interchange the sensors. Okay, like we put sensor from point B to T3. We also put sensor from T3 to point B. Okay, so we also interchange the sensors to make sure that the instrumentation is working well, and why we have a significant drop in the suctions in several months after this typhoon or during this rainy season. And when we compared the suction at different distances from the tree, so if you look at the before rainfall, the suction is quite high close to the tree, but as you go away from the tree, it becomes almost stable, I would say, more or less, with slight increase towards the end. And you see after rainfall, the differences becomes very negligible. It becomes almost a straight line, which is close to maybe less than 5 kilopascal. But before rainfall, the suctions are very high. Now, if you look at 10 days after rainfall, now this is very important. We call it recovery of suction. Okay, which happens due to the drying after rainfall. Now, when you see the recovery of suction, it's also give us a confidence that near the tree, the power of tree to suck water is more. Okay, so if you look at the recovery, okay, like 10 days after rainfall, the suction started increasing more near the tree again. So 35 days after rainfall, you see this black dot. Okay, it came back to the similar trend like the one before rainfall. So it means that because it's a cycle which I'm showing, like drying wetting cycle, so it confirms that our measurements are reasonable because they are showing very consistent trends before and after rainfall and even during the recovery period. So it means there is near the tree, there is a strong sense of water uptake, which is happening due to the tree roots, which is dominating the water uptake. But if you go away from the tree, the power of tree roots to take water reduces. Now, when you compare in the stage 2, okay, when the infestation took place, you see the trend is totally opposite. Okay? it changes from like, you know, from the one where you're decreasing with the distance away from tree, but here it's increasing on the other way. So you see there's a clear significant drop of the power of tree to take water. So I'm saying in the more simple terms, which we found it, as I said, were quite surprising when we were doing this monitoring. So when this kind of things happen in the field, we never expected this termite infestation at first point. It's just that, you know, after checking instrumentation carefully, after doing all the observations carefully, and then we started looking at the tree carefully, the leaves, the tomato conductance, and also the tree, you know, visually. Then we found this issue that there is an infestation, and which was confirmed also by the landscape authorities of the campus. They also confirmed this infestation, and then they have to remove the tree. Usually they cannot keep tree with infestation for a long time. So you can see there's a clear reduction. So the implication for in geotechnical engineering, especially if we are considering to use vegetation for our green infrastructure, is that we need to be very careful in the monitoring and also during the maintenance plan. Although, I mean, the landscape people, they for the campus they have regular, you know, inspection, but for when we're talking about using plants in geotechnical engineering infrastructure, we may not be having so regular inspections daily, and but the takeaway from this study is that at least we should have some kind of monitoring for soil parameters that could give an idea or indication that, you know, in return that there could be something happen to the tree. Okay, it's not just if there's something sudden drop in the soil suction, which is quite different from what we observed in previous years or same season, then it means there's something that could happen to the tree. So then it's a signal that we should check and go to the site to find out is there something wrong with the tree or not. So this is something that we observe after we found the soil readings to be quite different compared to the previous season. And when we compare carefully, like at different depths, so you have soil suction at 20 centimeter depth, you have 6. So you see, when we compare, I put this MPS. MPS is for the sensor which can measure suction in higher range, and JFT is a sensor which can measure suction in the lower range. Okay, and you have a precipitation together. Okay? So you can see usually, I mean, where you have precipitation, you have a suction drop, right, which is expected due to wetting. Right? Now, one thing is that this MPS sensor, the response time during the, I would say, wetting is okay. It's not so good. Okay, there's something which is questionable. For jet field tensiometer is still better, okay, during the wetting time. Okay, so for future, I mean, just for young scholars, I think there's a lot of scope. What I found is to develop, I mean, a more better sensors in unsaturated soil mechanics, especially for measuring soil suction. Still a lot of, you know, research going on. There are, I mean, several groups. You know, in UK, it's a Durham University, so they're still working on developing new sensors for measuring suction, especially in the high range. So still there is a lot of scope for young scholars. I mean, in the future, if they want to take up, I would say. I mean, this has always been a concern to measure suction in high range in a more reliable manner. So this is before infestation. At point A, you can see the suctions are quite high as compared to. So I put also a reference line. This for limit of jet field tensiometer. So when we compare with the after infestation, you see that all the suctions, irrespective of, you know, it's below, I mean, at 20 centimeter or below 20 centimeter, it's much lower. Though there was a trend which was going up and down, but the magnitude was significantly lower. Though it's a summer season, we expect suction to be much higher, but instead it went down quite drastically. So this is something which was quite obvious. So it could be initially, when I mentioned before, could be due to sensors, but we even interchanged the sensors. We did all the calibration, we checked everything. It was not. And finally, it was due to infestation, which we did not expect it before before we started the monitoring. So in the field, anything can happen. That's very, very important. Even sometimes your field monitoring plans, what you design in the beginning, you will realize during the monitoring that, sometimes you need to revise your plans. Okay, so that's why it's very important during the monitoring. You cannot just leave your data and come back. You need to regularly check your data from the field, regularly make adjustments, and revise your plans in the not every month, but in important times you need to check and carefully take decisions. So before termite infestation, if you look at for point B, which is little bit away from the tree, is this, but after termite infestation, you see the mostly these readings which were happening, I would say, close to shallow depths, they were affected after this termite infestation. So this is quite, I would say, a big change that we found in our readings of soil suction before and after infestation. So when I'm saying before and after infestation, so there is one hypothesis in this. Okay, you should keep in mind that I'm estimating a period when the infestation took place. Okay, now I cannot exactly point out when infestation takes place. Okay, that is not in our hand. Okay, it can take place anytime, but the visible, marks on the tree, you will see it quite late. Okay, you will not see on the time when the infestation starts. So when I say before termite infestation, after, it's the hypothesis that we suspect it happened during the month of May and June. Okay, in between these months, the infestation might have taken place, and this we suspected it from this graph, okay, canopy area graph. We suspected that there's an infestation taking place. I mean, before this, you can see this after 25 April, before 14 June. So very close to the month of May, we suspected there is infestation effect that have already taken place. So when I say this before and after infestation, you should not take it blindly that I know it when infestation takes place. It's just my estimation or hypothesis that it might have happened in that period. That at least the effect have been seen in that period. So this is point B. So point B, you can see, which is little bit away from the tree. Your suctions are much lower compared to point A, which was close to the tree. But overall, you will see still a drop down in suctions when this infestation takes place. And point C, you will see there is not a big difference, in fact, before after, because it is away from 3T2 quite. So you see that the readings for point C, okay, remains more or less in similar range. Now, this is quite, it gives us a confidence about sensors, because if for other points, we find that there could be something else, like for point A and point B, but then point C, we have quite similar readings. I mean, at least in the range, it was showing even after infestation. So it means point C, which is quite away from the tree, of course, will not feel much influence from the infestation, because the main phenomena for point C is still evapotranspiration, which is taking place from the grass, because we know that point C is full of grass. So there could be evapotranspiration, means combination of evaporation and transpiration from the grass, not from the tree. And then point D, you can see again, in fact, suctions are higher. Now, this was also point C and D. When your tree dies, we suspect when your tree power loses, the ability of grass to take water also increase. Okay, as I told you, there's a tree grass competition taking place. So for grass, it was a good news, maybe, because they could suck more water. So tree is not able to take enough water. So you will see that still a suction in an average overall, the suctions for the grass, it increased actually. I mean, especially if you see in the point D case. as compared to, I mean, even point C. So it means the suction instruments were showing, I mean, reasonable trend. It was something happened at point A, which have some effect on point B, but the effect on point C and D is not significant. But it's other way around. Instead, there's little bit increases in suctions in point C and D, which could be due to season, or as I also uh, uh, guess, likely also because of tree grass competition, the grass could take more water now because tree is not taking enough water. So you can see when we try to, do field monitoring, especially for this kind of natural landscape, it's not natural, it's a man-made landscape in a campus still, or even if you ultimately it will be natural by a long period of time, but still you will see there are a lot of processes. I show in the first slide, first or two slides, in soil plant atmosphere continuum. I mean, there are still a lot of processes that we haven't captured in this monitoring program. Okay, there are a lot of ecological process. Now these trees are still, not like very complete semi-deciduous trees. So if you have a semi-deciduous trees, which shed leaves in the winter and grows in the summer, we have done this monitoring before. I mean, during my tenure at IIT Guwahati in 2015-16. So when we did this monitoring, we found that for semi-deciduous trees, these leaves, when they trees shed their leaves in the winter, these leaves decompose on the surface of the ground, and this produces more like a litter on the ground, and also it increases the carbon in the soil, and it also leads ultimately to growth. The growth of new grass on the surface of ground. It's quite interesting. I mean, if you see this whole ecological process taking place, and if you want to understand how this ecological process affect our soil behavior, I mean, this is something very interesting, and we can take into account when designing this, going for these nature-based solutions in geoenvironmental engineering. So we also, as I said, captured for other trees, just for comparison purpose, because we expected though that tree T3, which is quite away from the ground, very close to the water table. Yeah, there's a river also flowing there. The suctions are very low. I mean, it's not even visible on the scale, but for tree T2, on an average, you can see the suctions are quite in the middle. So in general, in conclusions, found that the suction at shallow depths was highest near the tree stem, and it decreased, away from the tree. So we suspect, of course, with the increase in distance, your number of roots or the intensity of roots reduces, which reduces the soil suction. And also the canopy shading effects is higher when we are closer to the tree, which could also affect soil suction. I mean, because the water uptake will be lower near the surface as compared to the deeper depths. So because of the dominance of evaporation effect reduces under the canopy as compared to the root water uptake. So one is there's a competition between tree grass. There is also competition between evaporation and transpiration. Under the canopy, your evaporation is likely to be less, but transpiration can be more. Away from the canopy, your evaporation can be higher than transpiration. So there's competitions taking place. Okay, so all this, these processes are affecting the water dynamics in the soil. Okay. Now it's not easy to capture these processes. Also, you need actually much more sophisticated instrumentation plan to do that. Now, suction at very deeper depths, I mean, not very deep, but 0.6 meter did not vary significantly, which implies that the canopy shading effect, which is coming from the tree, and the roots, they are only within very shallow zone. And this we suspect also, we cannot generalize this conclusion because, these trees are planted on a man-made ground. It's a reclaimed island where the campus was built, and the root zone was not very deep. Now, if we go to a natural field where the trees are growing, the roots can be very, very deep. There you will find the zone of influence can be much deeper. So I would expect like this conclusion not generalized, but for this particular study, like for this particular site, is still applicable because it's a man-made site, and it's a man-made campus which was constructed maybe 6-7 years before the monitoring, and the roots were not very deep, and it was also constructed on a reclaimed, land, which is actually it's an island, right? So the groundwater table is relatively very high. So termite infestation have significantly influenced suction. So we hypothesize with a lot of confidence, okay, not hypothesize, but we have enough confidence that it was termite infestation, which we also observed visually, and also with all the data that we have from the plant health and also from the soil parameters, we are confident that it was termite infestation. The relation of suction to distance from the tree also change after infestation, with evaporation effects becoming dominant. And so, as I said, away from the tree, your evaporation become more dominant, okay, from the ground surface. And close to the tree, your transpiration is more dominant. And after termite infestation, in fact, it happened the opposite, that away from the tree, your suctions increase. And as I told you, the tree grass competition, it went in favor of grass, more likely because your tree is not taking water now. So there is also research going on in other areas where actually termites are very popular for mounds. Termite mounds are there, and there are researchers, they are trying to understand how the geotechnical properties could be affected by termite modification of the mound. So you will see that there's enhancement in the fine content due to presence of termites in the soil, which is due to the segregates due to their segregation, which actually act as a binder. So I understand that there's future research that can be considered, which is my thought or my dream, or not dream, but a wish. Can we think about using termite as kind of an engineers itself, the maintenance engineers, not to, create problems, but to help our geotechnical engineering. So it's kind of, thinking or taking termites as a living, organism for our own health. And this I would like to conclude. Thank you, and I hope not taken enough time. And yeah, thank you.
Thank you so much,
Thank you so
sir.
much, Dr. Ankit. So, Dr. Ankit, there are 1-2 questions on biochar also, which I'll be copying and sharing with you. So, meanwhile, we can allow have a couple of questions from the participants, if any, on today's lecture.
And there is one question in chat box, like, can the UAVs be used to monitor the slopes for deformation using image processing? This is the first one.
Yeah, there is a Ashutosh Kumar. I think, Ankit, you can also check it out.
Okay, for this UAV, depends. If you talk about the natural slopes where the vegetation is already growing, it will be not so easy to monitor, unless there is a very large deformation which is also causing a tilt in vegetation or the trees. But for small deformations, localized levels, I don't think it's so easy on natural slopes. But if you're talking about the man-made slopes, it could be possible one can capture some shallow, not shallow, but localized process, deformation, or but it also depends on the quality of your UAV that you are using. If you're assuming your UAV resolution of image and video is quite good, it's quite high, there could be possibility you can capture some kind of cracks on the slope, or some areas which can be vulnerable for infiltration. But to capture, I would say, or quantify deformation, I think it's still a long way to go. Yeah. Mhm. You can, as I said, if you have a large deformation, but to quantify, movements, small movements, seasonal movements, maybe not so easy. Yeah. Mhm.
One more question is there. Like,
Mhm.
please tell about the choice/selection of sensors for suction measurements of
Mhm.
vegetation and cohesionless soils. Suction measurement and of vegetation and cohesionless soils.
Mhm. See, when you're talking about, I mean, if you talk about sandy soils, more like, um, I suspect, I mean, what we found in our, I mean, experiments was, um, if near the surface, I mean, where the roots are present, your suction can go quite high. I mean, it can go easily above 100 kPa. So when I say above 100 kPa, we are crossing the the range when we can measure the suction using the jet field tensiometer, which is more or less direct measurement. But above 100 kPa, you already go for the ampere sensor, which is and also you have a sensor which is based on thermocouple. Okay, so temperature change based sensor or humidity based sensors. So above 100 kPa. So even in cohesionless soils, I would suspect, I mean, near the surface where the roots are present, you need a high suction range sensor. I mean, MPS sensor that we used, we found it more, I would say, uh, in terms of practical use, it's very easy to install. I mean, and its working quality is much better for a long period of time. There are other sensors also that we used before. Heat dissipation sensor is one sensor for suction in high range, but that sensor, the ceramic deteriorates much faster for a long term. So there are issues with this sensor when you want to use for long term in the field. It's mainly because of the deterioration that can happen. And in that case, you need to take out the sensor and check it. Otherwise, you will never understand the ceramic is kind of already deteriorating and the readings are not accurate. Although it will show reading and trend will be also shown, but the readings you cannot trust. Yeah. But at the deeper depths for the vegetation in the cohesion as well, but the deeper depths, you can use jet field tensiometers. I mean, which can reliably give suction measurement below 90 kPa or 80 kPa, I would say. Yeah. Because in sandy soils, we don't expect suctions to be very high at the deeper depths. Okay, so you can get measurements using jet field tensiometer. Yeah. Mm-hmm. Yeah.
Thank you so much, sir.
Mm-hmm.
Is there any question anyone want to ask?
Very nice, Ankit. Very, very thorough study on suction. So I am impressed with the level of detail you have gone into assessing the suction and also the effect of trees and vice versa. So it's really nice. Perhaps you may be doing but not presenting, but the impact of the suction on hydraulic or strength characteristics, and then perhaps the overall response of the geosystem. I mean, particularly, if you're talking about geotechnical systems or slopes, the performance of the geosystem. A lot of your work could be combined to assess those things because, we're talking about nature-based solutions. If you have these trees planted on geosystems, engineered geosystems, how suction is varying, and consequently, how hydraulic and mechanical behavior of the whole geosystem is going to be performing. So it's a very nice work.
Thank you, sir, for your advice, and I think it will be quite good to see how it can be combined and look into more broader aspect, as you mentioned. Yeah, that's right. Good point. Yeah.
Very good.
So if there is any more questions from the participants, if not, we'll move on. Thank you so much, Dr. Ankit. Such a nice presentation.
Think-
Yeah.
Okay.
Thank you.
I am on a hot seat now, Nilima.
Yes, sir.
Okay. So I'm going to share my presentation here. And let me see that slideshow from the beginning. All right. Thanks, everyone. Some of you have been attending every single day. So thanks for your patience. And I'm sure, you're learning quite a bit. So in my first two presentations, I talked about environmental remediation type of research projects. And the third and fourth, I talked about waste management, waste containment types of projects. And there are many other things that I could have talked in those both areas, but I wanted to give you some flavor to sustainability and resiliency. I don't see too much of hype about these in India, but if you go to US and if you go to Europe, in many other countries, they are, talking about sustainability and resiliency in, nothing but sustainability and resiliency. So all the conferences are now being themed under sustainability and resiliency. So this is a very important topic. So I'm going to talk about sustainability and resiliency in a little bit very general in the beginning. And then I'm going to focus a little bit more on geoenvironmental engineering. So hope you can take some of these things and apply to what you're doing. So what is the problem? The problem is the way we do engineering projects now. Geoenvironmental engineering is one of the engineering specialties, but any engineering project you take, even like not necessarily in civil and maybe even other types of project that you deal in general in engineering, the way we design is first we look at the codal requirements or regulatory requirements. What are the requirements, right? So that's kind of the first thing that we look at it. And then, of course, we start with the minimum codal requirements, and then we do the analysis, and then we do the design for safety, right? So we do that one, and then we teach technical design in our courses, and of course, a lot of professionals are very good in designs to ensure you have a adequate factor of safety or conditions within the allowable limits. And then once you design it, if you have alternatives, what we see is which one is easy to construct. That's kind of one practical consideration. Then you want to see which one is going to cost out of the technical design options and which one is faster to construct. So this is the standard practice now, right? We always do these things, and there is nothing wrong, doing these things. So we have to continue to do these things, but we don't consider some additional factors which are becoming extremely important. One is the sustainability, and then we also need to look at the life cycle thinking, and then you should look at the resiliency. If you consider these things, we don't consider these things in our current practice. So if we consider these things, actually you will come up with a very new innovative solutions. I call it out of the box solutions that are effective. That means they will do the job that you are intending to achieve, and also most importantly, the solution is going to be much more economical than a traditional solution. So what I'm suggesting is that everything that we do now, we need to add additional consideration of sustainability and resiliency. So you ask that question, which option is more sustainable and more resilient? And then if it is not, then can we think about something and that could be, okay? So that's the idea. So then, you need to have an idea about what is sustainability, what is resiliency, right? So if you want to incorporate sustainability and resiliency, so then how do I incorporate in the design, right? I'm going to just give you how to incorporate resiliency in the design, how do you incorporate sustainability in the design, but we need both sustainability and resiliency. So how do we do the sustainable and resilient design, right? So that's kind of the agenda for presentation today. So sustainability, there are different definitions for sustainability, but I'm sure you have seen this definition that is given by UN World Commission on Environment and Development, that basically says that development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So I like this definition. It's a very, succinct and very powerful in terms of conveying the message. Basically, what it is saying is, don't mess up anything that will affect the current generations and can affect the future generations. So the question is, do we need to worry about, is there anything going wrong that we have to worry about current generations and future generations? So one big concern that we have is the global climate change. And we are seeing that the climate is changing, and we are seeing a lot of extreme events that are happening: sea level rise, floods, droughts, and wildfires. Those are all happening. As a result, a lot of the infrastructure is being affected. Even natural systems are going to be affected, and that is affecting the current and future generations. That's one of the biggest concerns. That's why we need to worry about sustainability. The other big concern is the exploding population growth and consequent impacts. Look at the world population. It has been increasing, and it's going to. So if you have more people on the planet, what will happen? All these things are going to happen. You are going to deplete the natural resources. You're going to increase the waste, increase the pollution. You're going to damage the ecosystem, loss of biodiversity, urban sprawl. All these things are going to happen just as a result of increased population, right? So if you look at the relationship between the global climate change is mainly due to the greenhouse gases, basically carbon footprint. So if you look at the carbon footprint versus population growth, there is a 1-to-1 correlation. That means what? If I want to come up with a one concern that we will, one concern going into the future is, how do we handle this, increased population growth? Obviously, that's a sensitive issue. We're not going to talk about reducing the population growth. The main challenge is, how do we do things differently and have sustainable development in spite of population growth? So that means we have to do something different than what we have been doing. So this has been realized at many levels. United Nations is the agency that does at a global level, and they realize that we need to be worried about sustainable development, and they define these sustainable development goals. So we should be striving all our activities, and including our infrastructure design, in a way that contribute towards these sustainable development goals. There are 17 sustainable development goals, and in each goal there are targets, 169 targets, and then you have 247 indicators. So actually, UN monitors the different countries for these indicators, and every year they rank the countries. So I don't know where India is, but India is somewhere over 100 in terms of the countries. And the US is also somewhere down the, not at the top. I think some European countries are in the top. So in this one, you see this one, engineers, civil engineers and geotechnical engineers can play a major role. For example, clean water and sanitation, right? So you want to make sure that your water resources, surface water, groundwater, all of those things are taken care of so that you have a clean water for consumption, affordable clean energy. And then you look at sustainable cities and communities. That's where we can play a lot of important role as a civil engineers and as environmental. And then dual is the And then the number 12 is responsible consumption and production. That's where all the work related to beneficial use of waste materials come into picture, right? Can you hear me?
Yes, sir.
Okay, very good. So then, you have all these things, and out of all these things, you can see, these all the SDGs are interlinked, and the role of civil engineers is significant. And out of all these things, you have also climate action. Remember that the first concern that related to sustainability is global climate change, and we need to act on that one also. The point I'm trying to say is, a civil engineer should play a major role towards achieving the sustainable development goals. So we need to keep all in mind. And if we do things with additional look through the lens of sustainability and resiliency, we'll be accomplishing these goals. So let's say, you are listening to me and you never worked on sustainability and resiliency. You ask this question, what can I do? So as a civil engineer, okay, this could be a enchanted territory. So, you may say that, oh, this is not civil engineering. This is not design of a foundation. This is not a design of wastewater treatment. This is not, nothing to do with me, right? It's not relevant, not interested working on. Then you say, okay, I want to do something, but it's not my technical area or expertise. Okay, let other people who have expertise can let them work on it. But I'm going to focus on what I am used to it, right? So that could be a tendency of people. And some people may say, oh, this subject of sustainability and resiliency is the sustainable development is complicated subject. I'm not going to deal with that. And then you say, oh, this is a global problem. I'm working on a project here in this area. I'm more interested in solving the local problem than global problem. So you can come up with all these excuses, but the most important thing is that everybody can do something towards the sustainability and resiliency. And you have to look at the sustainability projects at different scales. The global scale, the different countries are working on these agreements, climate agreements, and there are sustainability initiatives at the global scale. National scale, many countries have energy policies, move more towards the renewable energy. Regional scale, there are a lot of projects. The business or institutional scale, there are projects. Now what we're talking about is the technology scale, where engineer, you can do day-to-day basis, whatever you are doing now, right? Well, we are not asking you to do anything different. Whatever you are doing now, you're dealing with materials, you're dealing with designs, you may be designing with products, you may be designing processes, systems. Can you ask this one question? What I am doing is it sustainable? Is it resilient? Ask that question and see, if you answer yes, okay, you are doing excellent. If your answer is not, then can you do something different, contribute towards the sustainability and resiliency so that we are all going to be safe on this planet, current generations and future generations can enjoy their quality of life? So this is the question. So don't get scared of getting involved in sustainability. You can do it in multiple scales, but at the most you should be able to do things that are you are already doing, but doing slightly different. So sustainability is interesting, looking at things sustained for long term, but we have a urgent problem. The urgent problem is the climate change. Climate change is due to increasing greenhouse gases. These have been increasing. We haven't paid too much attention, and then we already have too much of these greenhouse gases. What are the greenhouse gases? Basically, carbon dioxide, methane, nitrous oxide, and the CFCs, SCFCs, but predominantly carbon dioxide, methane, and nitrous oxide. So these concentrations, have been increasing, and we already have so much in the atmosphere, and the climate, we change the climate, and we are witnessing the impacts of the climate. And it is very difficult to, reduce these things overnight. And then moreover, if we don't try to reduce these things, if we keep on adding more, situation is going to get worse. So the point is, we cannot really have greenhouse gases continue to increase, but we will, take activities to reduce it, but it will take some time. We are not going to be able to reduce, for foreseeable future. That means we have to deal with impacts of climate change. What do you mean by impacts of climate change? We are seeing the temperature changes, extreme temperature changes. Look at newspaper or look at news online. There is news about climate change every single day, right? So you have extreme temperatures and sustained changes in the average temperatures, decreased permafrost, precipitation, heavy precipitation, all right? Increased flood risk, decreased precipitation, and increased drought in some areas, increased landslides, sea level rise. All these things are happening. And mainly, more and more of these things are happening because of the recent climate change impacts. The wind, increased intensity of hurricanes, increased intensity of tornadoes, increased storm surge intensity. If you live, near the coastal areas, you are witnessing all these things. And in some areas, you have wildfires. U.S., for example, hundreds of acres of the forests are, on fire, and this is a big problem. And then, if the impacts are really affecting people, these are not, hypothetical things are happening somewhere. Some things are happening and people are, really facing this. So this is one example of road getting eroded due to increased sea level, increased, surge. And then residences, getting flooded because of the increased flooding, right? And the landslides, I have a lot of pictures of that one. Many of them are due to this extreme precipitation that was never the case before, and causing a lot of landslides. So you see these impacts happening globally. It's not like one location or one country. So these things are happening. India is also witnessing a lot of things that never happened before. They're happening. So extreme temperature, extreme flooding, all these things are happening. So you see these things are affecting our day-to-day lives. You're not saying that, okay, these things are happening in remote areas, people are not being affected. People are being affected. So those people who are being affected or face the difficulties, they do realize that, it is urgent that we need to consider the climate impacts, and we need to design our infrastructure considering the climate impacts, so that we don't have to go through these rough times again. So people are actually willing to, pay more taxes so that engineers can build the infrastructure to address the climate impacts. The sustainability is kind of, very difficult to convince, people to buy in, because that's like a long-term impact. But people are really wants engineers to do something with climate impacts. And these things are, these events are increasing, every year. So it's a big concern. And then loss of damage due to these, disasters is very, very high. And then if you look at the projections of what is going to happen. So if you are ever interested in climate change, if you want to learn more, the best resource is IPCC. Don't look at any books, any papers. The main resource is this, you should get hold of these reports. You can download free. So this IPCC report, you will see the physical science basis, and they are actually showing that we are going to have extreme heat, heavy rainfall, drought, fire weather, ocean warming. They also have these two other reports they released. We need to assess the impacts, and we need to be able to do the vulnerability and adaptation, and we need to do the mitigation of the climate change. So adaptation and vulnerability and adaptation is coping up with the situations, but mitigation of climate change is to reduce those greenhouse gases, which are the root cause of the problem. For all of these things, like look at the photo, using the solar energy. So if you use the solar energy, so you will not be using fossil fuels. Coal is a main culprit of a huge amount of greenhouse gases. So you are, by resorting to the solar energy, you are mitigating the climate in a way that you are avoiding the emissions by coal burning. So the concerning, issue is that we are going to see increasing greenhouse gases into the foreseeable future even if we make an effort to reduce the CO2 emissions. So that means this issue of climate change impacts are going to be faced into the near future, and we cannot tolerate those impacts. So it's important to consider those things. So we need to think about resiliency. What is resiliency? Is basically you designed it, it's performing fine, and then let's say you have an extreme flooding event, so you compromise the performance, but then when that event goes away, then the system should come back to acceptable performance, or you should increase to the same level as before, or it should perform better than before. So that's kind of a, it should bounce back. That's what we're talking about. So how do we do that one in our design? So our codes are not yet address these climate change impacts. So the codes are way behind. So that's why engineers cannot wait for the codes to be changed, and you say you follow the codes, but it's a moral obligation for engineers to revise the design criteria or add on this additional design criteria, so that your engineer system or your design can be more resilient. So what we are talking about is revise the design criteria to address sustainable change in the average temperatures, increased heavy precipitation events, and increased coastal flooding, increased intensity of storm surge, sea level rise, and then increased wildfire severity. So we are talking about adding on these additional criteria to whatever you are designing. How do I do that one? So it's called climate resilient design. So what do you do is, okay, you have a project at a particular location and you identify what are the climate change hazards of concern. You can get a lot of information about these things from different sources. Okay, then what you look at is, okay, for the identified hazards, how is your system is going to perform? Okay, so that's the this is called vulnerability assessment. Obviously, if I'm going to get extreme flooding or extreme precipitation, how my engineer system is going to be performing. It's like a vulnerable, like you do, right? You take the loads and do the analysis. Same thing, we are, assuming certain additional loading criteria. It could be precipitation, temperature, whatever it is, and then see if your system is going to be safe under those conditions. That's called vulnerability assessment. So then let's say, the system you designed is not going to be safe. Then you have to add on some additional features. So you need to revise your design to accommodate that one. So these are called, incorporating some resiliency measures, right? There could be multiple options as a remedial measures. So then you have to prioritize which one I need to go with, right? That's called resiliency measure selection. So then okay, I've selected this measure so that I can cope up with this extreme precipitation or drought or something. Then what you do is you incorporate that one, you design it, and you go for construction. Then you have to actually monitor the situations with time. So with what is happening is, with the climate impacts, climate change is, even though there are so many models, so much variability in the predictions, because nobody can accurately predict what will happen next year, year after. So only way is to assess what is happening every year and see what you have incorporated in your design, the resiliency measure that you have. Is it still adequate? If not, then you have to go back and revise it. Okay. So periodically you have to look at climate impacts and see if your design is okay. If design is not okay, can you assess and revise your design. So that's why what is becoming this is called adaptive capacity evaluation. What is becoming important is you need to have designs that are flexible enough to change in the future. Don't think about fixed design. If you design it and then you cannot change it anymore in the future, that's not a flexible design. You design it such a way that in the future it needs, that can be changed. So that's the thing that you have to have, that criteria you have to have it now, so that you can be able to do this one. So this whole framework requires engagement of stakeholders. It could be public, planners, designers, owners. because no matter how you do it, there is always a risk of unknown climate impacts, uncertain climate impacts that will affect your system. So, you cannot really design for the worst case scenario. That's going to be, too expensive and maybe not necessary. You don't even know if that kind of a climate change is going to happen or not, right? But you will do the best. But there is always a risk. So you need to, convey that risk to all the stakeholders. The public is there. Let's say, they are right next to the hilly area. You cannot guarantee that, they are going to be safe forever under any climate conditions, right? So for assumed climate conditions, it's fine. But, you cannot really design for the worst case scenario. That's going to be expensive. But you need to tell them that, there is a risk still. I always show this simple example of resilient design. So basically, this is in New Orleans, this house is being constructed. So you have this foundation. So at this area, they were expecting flood level in the future due to climate impacts to rise up to this level. So the rise that they have for the foundations up to that level. So that means, that right now they are preparing for the future. This is called resilient design. So if they can rise it, you can increase the foundation height and then build this house. So in the future, if this area gets flooded, this house will not get flooded. Okay, you are doing your best judgment, best analysis of the projections, and then taking care of that one. Do you guarantee that the flood level is not going to be more than what you have assumed? You cannot guarantee that. But that's why climate mitigation is important.
Okay.
So then let me give you another example. So we have these lot of landfills right next to the coastal areas. Now, okay, they are fine now. They have been fine now, fine for many years. But now with the climate impacts, so the water level is going to rise. They're going to be surge. So now we are providing this protection on the sides on the water side, so that when you have storm surge, you're not going to have any impacts. So there's you can see here kind of a seawall, kind of it incorporates some green approaches to this one, right? So the kind of a wetlands that you have here, and so that's become some more sustainable option. Now this is one site, where this site is contaminated and it's right next to the coastal area. Okay, so if you don't do anything, this whole site, contaminated site, is going to cause contamination spreading and going to be a big problem. So beforehand, we want to do this sheet pile wall. So they're building the sheet pile walls here so that the sea level rise or surge that happens, that will not impact the contaminated site. So this is like building the barrier to maintain the conditions. So here is one site, this is an island in Hawaii. So at this site, this sand is contaminated with really a pesticide, very, very toxic to the people. Don't live on that planet. You have all this birds live on that planet. Ecological protection is extremely important, not just people. So if they consume this pesticide, they're going to die. So what can be done for that affected sand, right? Because there's going to be rise, the sea level could rise and it could have a surge. So there is no engineering you can do it to make sure that that sand is not going to be spread when you have these extreme events. The only solution they found is the complete removal of that sand. So that is the best option. So the question is, okay, we can think about these resilient options, but the root cause of the problem is greenhouse gases. So if the greenhouse gases are not controlled, if the greenhouse gases are going to keep increasing, our vulnerability assessment is going to become worse and worse, right? So we need to be thinking simultaneously. We need to be thinking about reducing the greenhouse gases, and so that's called climate mitigation. And then in the long run, we need to be looking at the population growth and associated concerns. So the climate mitigation is only addressing the climate problem, but we have a larger problem of population growth and the sustainability into the future. So that's resource conservation, or it could be pollution, it could be economic impacts or social issues. So we need to consider that one. So how do we consider sustainability? I told you sustainability definition is there, that UN definition, but that is not really a functional definition. The functional definition, you can find the different functional definitions. The one ASCE definition is this. In this one, what I highlighted is the triple bottom line. They say environmental, economic, and social conditions in which all of the society has the capacity and opportunity to maintain and improve its quality of life indefinitely, without degrading the quantity, quality, or the availability of natural, economic, and social resources. So that's kind of what it is that triple bottom line is the most important word in this definition. So we need to be thinking about environmental impacts, economic impacts, and social impacts. This is the triple bottom line. So we need to consider all those things when we design something. And if you consider all of them, make sure that the negative impacts are reduced and positive impacts are increased. If you do that one, then you are going to be contributing towards the sustainability. Now, as engineers, we want to assess sustainability of our designs. So that means we need to quantify the sustainability. In order to quantify the sustainability, you need to have what are the environmental indicators we're going to look at, what are the economic, what are the social indicators, and then we need to be able to calculate them. So those are called metrics, and then we need to have tools to calculate those metrics. So we can calculate those numbers and see how sustainable is our particular design is. Environmental sustainability, what indicators that we can use? Energy, right? If you use the less energy, you are more environmentally sustainable. A carbon footprint is one thing, right? If you have less carbon footprint, you are more environmentally sustainable. Smog, acidification, all the environmental impacts. You need to pick these indicators that can have metrics, and then you should be able to calculate those metrics. And you have to look at the tools. Like there could be specific tools depending upon the application that you're dealing with. But the general tool is life cycle assessment. Life cycle assessment is standardized ISO methodology, where you look at different life cycle stages, and then you put the raw materials and energy, and you need to do that one. And then you get your products, and then what are the environmental emissions. So those are the things that you are interested in: atmospheric, waterborne, and solid waste. So this is what is a life cycle is. You need to look at these raw material acquisition, manufacturing, operation and use, maintenance, or construction, and the recycle and waste management. For each of these stages, what raw materials you need, what energy you need, and then due to this manufacturing of the materials, acquisition of the materials, so then you have these environmental impacts that come out. So that's what you're looking for, environmental sustainability. So LCA is before many years ago, this was taught in mechanical engineering and manufacturing divisions and other things, but now this LCA is being taught in every engineering field. So this, according to the ISO 14040, there is a set procedure for doing it. So everybody does consistently the same way. Unlike other methods, you may have some people doing some other way. So this goal, scope, and the life cycle inventory, life cycle impact assessment, and the interpretation, these are the things that have to be incorporated into this one. So economic sustainability. So the direct economic cost, how much is going to cost for construction. That's the only one indicator. You need to look at indirect, direct costs, direct benefits, indirect economic costs and benefits, social cost of carbon. That means monetized, environmental costs. What are the employment opportunities and human capital? Induced economic costs, benefits, project lifespan, and flexibility. So here things become a little bit hazy. We are used to calculating how much is going to cost, but when you talk about what are the benefits the project is going to, result, or avoided costs, so we don't have an idea. So this is where additional thinking, additional expertise, if you're not familiar, you may have to work with other collaborators. This is what we're talking about is all economic, direct or indirect costs and benefits that we need. So there are life cycle cost analysis, cost benefit analysis methods that people have developed, and we have to use those things. The third aspect is the social sustainability. So this is how people affected by that project, right? What is happening to those people? This is like a community, right? Individuals or community. So their quality of life and their job opportunities or their environmental situation, all those things. So when you talk about people, defining the indicators becomes extremely difficult, right? So these are kind of some indicators you can think of, and then how do we quantify these social indicators, right? And what are the tools that we have? So this is the gray area. Social sustainability is the one. It's very, very challenging thing. In 2013, I developed a social sustainability evaluation matrix. Basically, I consider different social aspects, and I developed a rating system, and that can be used. Also, you can now there are a lot of efforts to come up with the social life cycle assessment. Those things are coming up. So you will see more efforts being made in developing the tools for social sustainability. As I said, like civil engineers, or from sustainability and resiliency point of view, we need to be thinking from life cycle point of view. So a lot of times, we design something. So you say manufacturer is going to get the materials and do the construction, and then we are in charge of the maintenance. So the construction and maintenance, that's the only thing that we consider. But in reality, if you want to really do the sustainable project, what resource materials you need, going back into the mining, and then manufacturing of the materials. You need cement, steel, what kind of resources that you need, what kind of emissions that you're going to have, transporting the materials to the site, and during the construction, what equipment you're using to construct, and during the maintenance, what are you doing? At the end of the life, it could be down the road, 50 years from now. Don't say that you don't care about what is not going to be alive. You don't care about what's going to happen, end of life. No, in the future, we're talking about sustainability of current and future generations. When these guys, these structures or these designs reach their life, they want to demolish. Then how much of that can they recycle, and how much they have to dispose? So this is the thing that we need to think in terms of the sustainability. So for each life cycle stage, you need to look at triple bottom line: environmental, economic, and social. So what I'm trying to say is, if you really want to quantify the sustainability of your project, triple bottom line is the best way to do it. And for that, you need to have environmental indicators, you need to have economic indicators, you need to have social indicators. And each indicator has the numbers, and we need to have tools to calculate those numbers. Let's say, you define these indicators and you got tools to calculate those metrics, and you calculated it. But we have to calculate those metrics for each life cycle stage: raw material acquisition, materials manufacturing, transportation, construction, operation and maintenance, and then at the end, waste disposal, right? So the triple bottom lines you have to calculate for each one. So if you do that one, you go to get, or you can add them up or whatever you want to do. You have a lot of these environmental indicators. You have economic indicators. You have social indicators. I have if you put this in Excel spreadsheet, you have a bunch of them, maybe 20 of them, 30 of them. Now, you won't see all of them on the good side for a particular design. If that is the case, then you say, okay, I see all the good numbers for this case, I'm going to use that design. And second and third is, I'm not going to use it. But what happens in reality is, you are having options 1, 2, 3, but each option, some of them are good, some of them are bad. So these indicators, you will see, contradicting results for different indicators. Now, how do we make sense of when you have these indicators, they are varying, for some cases, negative, some cases is positive. So how do we make sense out of all those indicators? So that's where, is there a way that we can consider this multi-criteria thing and into a sustainability index, multiple indicators, and can we convert into sustainability index? So if you can do that one, so based on the sustainability index, you can see how sustainable is your design, or you can optimize that design to be more sustainable. Or if you have different alternatives, you can look at which alternative is sustainable, right? So then how do we calculate this sustainability index? So that's where you need to use the multi-criteria decision analysis. It could be, any multi-criteria decision analysis that you can look at it. The MIVES is one example, TOPSIS is one example. And then, when you look at these indicators, all indicators are not necessarily of equal importance, right? So you may have to weigh them. Okay, I think this environmental, this emission is more important, and this emission is not that so critical. So you can, how do you assign that weightages based on the analytical hierarchy process? So if you can do that one, so you have environmental indicators and criteria requirements, and we follow this methodology. There could be different methodologies. This is the methodology that we developed, and we use this one on all our projects. So so main thing is to calculate those environmental indicators, economic indicators, social indicators, and then weighing factors. You don't have to worry too much about weighing factors. As a baseline, you can consider all of them are equally important. So you could do that baseline analysis. After that, you can do the sensitivity analysis. So this whole process gives you the sustainability index. I suggest you to look at this paper that gives you the all the details about that one. So just let me show you a simple example of how this can be done, right? If you see the example, then it makes sense like how to do it. So what I chose is a geoenvironmental case. Okay, this we have a site which is we have a contamination issue. We need to address that. This is in state called Iowa, very next to my state, and the place called Cedar Rapids. That's a city. So this is a site we are looking at it. So there is a river that goes through here. So you see the river goes through here. But what our concern is these ponds. These three, you see these ponds. These ponds are divided into three parts. So here, ponds or lakes, you can call it. So this is the river that is going through it, and this is the whole area. And you look at this one, this North Lake, and this is the South Lake, and this is the West Lake. So this, you can see the area of these lakes. Total about 150 acres, each one 80, 10, and 60. And there is a railroad line goes across this one right now. And then it's, there is a power plant here, coal power plant that used to use the water from here and then used to discharge the rejected water in there. So the water, was being used, and they used to put it in there, but that the power plant was closed. And what happens is there's outfalls. So when it rains in the city right here, all around that area, all that runoff comes here and then gets into these lakes. And then, overflow goes into the rivers. So when the runoff comes there, it's going to carry a lot of sediment, a lot of contamination, and all that sediment, in these lakes are contaminated because, there is a bypass flow under the bridge here. So, the sediment, wherever it is coming in, you're going to see a lot of sedimentation there. And then, in all the lakes, the sediment could be contaminated. So that the contamination, could be pesticides, PCBs, PAHs, and metals. That's what found in these lake sediments. Now, what they want is, see, the site is very close to the city. It's beautiful, river, and you have these lakes. And now the problem is these lakes are contaminated. Very sad. So the neighbors, the people there in the city, they want to convert this into a park that people can use, right? So this is kind of an artistic view of what they want to have. So they want to take out that old railroad bridge line, and they want to put this bridge, and they want to clean up the lakes, and then they want to use for recreation, kayaking, boating, swimming. They want to do that one. So if the sediment is contaminated, you cannot do all those things. Contamination, exposure, and risk is taken very serious in the US. So you cannot do these kind of things. So we need to clean up the sediment. Then only we can convert this into this recreational park. So at this site, you can see, at the bottom, you have alluvium, the silt and clays are kind of deposited there. Right by the outfalls, you see some sandy formations. So that's kind of a site geology. Now, the contamination, when you have it, as I said, if the contamination exceeds certain levels, then it is a concern, health concern. If it is very small amounts, you don't have to worry too much. In the US, we have standards to look at, okay, what concentrations you have, whether the concentrations exceed the risk-based levels. If they exceed, then you have to clean it up. So the risk assessment was found, is made, and then samples that exceed the limits are need to be remediated. If you look at this one, this was sampling was done many years ago, 1994. See all that orange colors that you see, the concentrations exceed the levels. Concentrations exceed the levels. Even the pink and the blue lines that you see, that means every location that they sampled, the concentrations exceed the risk-based levels. That's not good. So, the health concerns are there. So then they didn't do anything at this site over the years. And then they went back and then they did the sampling in 2017. And then look at this. So the main thing is this orange. See the orange blocks you see? That is the main concern. That's the risk-based levels. So you see, you don't see orange here. So concentration is actually naturally degraded. This is basically natural attenuation. So you always have microbes in the soils and sediments, and they were degrading the contaminants. But this area that you see here, you see concentrations are still high. They're higher than this. Maybe if you let this concentration, if you don't do anything for long period of time, maybe they will disappear. But as long as you control the source, right? Stormwater outlets and everything, you control it, and then this will be good. But they want to convert this into a park right now. So so this area that you see here, I highlighted this area, that is the area that exceeds the risk-based levels, and then we need to do something. We need to do the remediation in that area. So that's higher concentrations, and we need to do something with that area. So what can we do? This is where engineers come into play. So let it naturally degrade. As I said, this is not an option because it's going to take many years, but we want to redevelop that site into a recreational park right now, tomorrow, right? So dredging and disposal is one option. Conventional capping and modified capping is an option. Dredging and disposal, you can think about it. So basically scoop that all the sediment and truck it to and dispose in a landfill. Okay, so that's kind of a very kind of common thinking you can have. This conventional capping and modified capping, what is so you don't take out the sediment. So let's say you have a sediment, you put these layers of sand and gravel on the top of it. So what you do, what happens is the sediment is contained. Okay, the contamination is contained there. So it's like putting a cap on it, right? So that's a commonly used solution for it's a capping. But instead of this one, this is called modified capping or reactive capping. What they do is instead of putting all these layers, the sand and the stone, all these things. So here they put a reactive core mat. Basically, it's like a GCL. They put some material inside, and then they have a geotextile on both sides, and they have a sand and riprap. So this material here is, as the contamination tries to diffuse from the sediment into the water, you're going to have a reaction taking place. You have a clean water coming out. So that's kind of modified capping or reactive capping. So maybe we place this instead of dredging and taking out a landfill and putting in there. Maybe put this capping at the on the top of the sediments, or we put the modified capping. Now the question is, which one is sustainable, right? So let's think about designing these things. So monitor natural attenuation. What can you do? It may be expected 20 years. Dredging, you need to excavate and dispose. Conventional capping, what are all the materials that you need, and then how do you place them? Modified capping, what are the materials that you need? How do you place them? So this is, you need to have this, at least preliminary design aspects of all these three options. So once you have those options, then you can do the sustainability assessment. I want to know which one is more sustainable. Environmental, economic, and social. I want to do the triple bottom line assessment that I mentioned before. So environmental assessment, I will do with a life cycle assessment. You can use the different methods, but when you do this life cycle assessment, you get the impacts like this one. So you calculate the environmental impacts: ozone depletion, global warming, smog, acidification, eutrophication, carcinogens. So all these things, these are different impacts. If you talk about carbon footprint, this is only the global warming. When people say I'm doing the carbon footprint analysis, you're doing only one of these things, okay? But when you do the LCA assessment, you get all these environmental impacts, which is really great. So just looking at the carbon footprint, let's say global warming, M&A, you don't even see that, it's so small because you're not doing anything except monitoring it. Dredging is this yellow, and then conventional capping is this red, and then modified capping is this one. Basically, with the highest, it's normalized. So this is the highest. Out of that, you get this one second, and this is the third. So why dredging is coming out as a less carbon footprint? Because you have to transport all those materials, right? You have to get all those transport materials, and also you have to regrade the sediments. So that involves a lot of work. So you see this one. So you say that from carbon footprint point of view, hey, dredging and disposal may be the best thing, right? The more capping is bad. But then you look at other options, right? And see where consistently which one is more sustainable, which one is not sustainable, right? So and then you can do the different databases that we analyzed, where the data is coming. And then transportation makes a lot of difference in sustainability assessment. If you actually look at where these materials could be coming, and you can do the assessment. Or sometimes what we do is, okay, let's assume that all the materials are available from the same distance, and see if the impacts are similar. So the modified capping versus conventional capping, the modified capping comes out to be better than conventional capping. Okay, so we did that assessment, and then we do the economic sustainability assessment. Which one going to cost more, right? So look at this one on the scale like this, on a split scale. M&A is going to cost less, even though you're not doing anything, you have to do a lot of extensive monitoring. So that's going to cost a lot of money. And then dredging and disposal is going to be very expensive. Here I'm showing the direct cost and the social cost of carbon. That's like basically the monetized carbon cost. And then this is the total cost. You look at the conventional capping, modified capping. So you have the cost information. And then social sustainability, how people are going to be affected by this different implementation of these different remedial methods. So in my SSCEM, that's the tool that I developed, social sustainability evaluation matrix, we look at individually how a person is going to be affected, how a community is going to be affected, how the community's economic situation is going to be affected, how the community's environmental situation is going to be affected. So these are the indicators. These indicators you have to come up with based on your own project specific, and these are the different options that we have. You use the scale, 1 being the best and 4 being the worst. Again, that scaling can be different, and based on that, we did a survey. Basically, you prepare this questionnaire and ask people to rate, okay, which one is better from overall health and happiness of individual people point of view. So they give you, they don't like the M&A. M&A is a monetary natural attenuation. So you're not doing anything. So they say like you're trying to find an excuse for not doing anything. But they like modified capping or conventional cap. So in the order, they preferred the modified capping. But in many other cases, you see that they don't like the M&A. And you can look at the social sustainability assessment, the numbers there. Now the question is, you have environmental indicators, economic indicators, and social indicators. So how do we make a final decision, right? As I mentioned, we use this framework. We calculate the sustainability index. I'm not going into details of this one. There's a paper that goes into all the details, so you can look at it. And then if you put all those numbers, you can calculate the sustainability index. So this monetary natural attenuation comes out to be a high number. And then second best is the modified capping, then conventional capping. And higher the number, better it is. So you can also contribution of environmental, economic, and social aspects to this one. And here we assumed all the environmental, economic, and social aspects are equally important. So now what I'm going to do here is, okay, I'm going to say my social aspects are going to be much more important. Here, people comes first, right? And then economic and environmental. If I do that one, so this modified capping comes out to be the best option. You see, that's the highest thing. And then if I change to, okay, economic is the my prime criteria, other things are okay, then M&A comes out to be on the top. And then if I say, okay, environmental is the main concern, then M&A comes out to be the. So you need to do the sensitivity analysis and then make the decision. So the point here, the last point I want you to look at it is, okay, even though we came up with these numbers and this assigning the environmental, economic, social can change the conclusions different, which one to use, right? But that eventually not necessarily go with your calculations. The stakeholders' preference is the most important aspect. What do the people want? For example, people want, hey, I don't want capping. You still have the contaminated sediment in there. I don't want any contaminated sediment in my lakes. Dig it out, dredge it out, and take it out. That may be the only thing they wanted, right? So you have to go with that one. Even your numbers are showing that other things are better from sustainability point of view. Sometimes, the stakeholders' decisions or preferences, overpower the other considerations that you may have. So it's kind of a very important decision making at the end. Now, what I want to say is sustainability and resiliency. That's only about sustainability, right? Environmental, economic, and social. Now you need to think about resiliency. So is it resilient? Resilient is about coping up with the climate changes, climate impacts, right? Climate mitigation is like, you are looking at the best option to minimize the environmental, economic, and social negative impacts. So how do we do that one? So there are not many good frameworks that assess the sustainability and resiliency together. So we developed this framework wherein, you need to look at the triple bottom line and also resiliency together, all of them together. So this is the framework. They have four phases. I have this publication. I think I explained a lot of details in this publication about this framework. So you do the resiliency assessment first, and then do the sustainability assessment. If some system is not resilient, what is the point of looking here at the long term? When something's happened tomorrow, it's going to collapse. And what is the point in thinking about long-term sustainability considerations, environmental, economic, and social, right? So the phase one is seeing whatever you're proposing, is it sustainable? If it is sustainable, what are sustainable, resilient options that you have, and then subject them to sustainable. So you are basically addressing the resiliency and sustainability. So at the end, you end up with a system that is resilient and sustainable. So same project, let's say, okay, say you have all these options, as I mentioned. So you have a dredging and disposal, conventional capping, and modified capping. I showed you the sustainability assessment, but I want to be able to see, tomorrow, if that lake gets flooded, right? You think whatever how these remediation options will perform. So that phase one that I showed you in the framework, if you run through those numbers, then you get this resiliency index. And you see that dredging and disposal has an index of 1. That's the most resilient option. The conventional capping and modified capping is not going to survive. If that lake was subjected to complete overflow, this conventional capping and modified capping is not going to work. Dredging and disposal means you took out the sediment already from there. So that's would be the best option. If you're taking out that one, will be the most resilient, or basically that's the best solution under extreme climate impacts that could happen. So based on this assessment, dredging and disposal is the best option. I don't even have to think about conventional capping and modified capping because they have low resiliency index. So I can say, okay, dredging and disposal, and then I look at dredging and disposal itself as the only option. Then I can assess that sustainability aspects of that one particular option. How can I make that one more sustainable? Right? So you can look at one option as a sustainable. But what I did is, for just the sake of exercise, I ran the sustainability numbers. Let's assume the sustainable resiliency is not a concern. and then I ran these numbers for sustainability. If I go another step, it shows that modified capping is more sustainable. Okay, that makes sense, but this comes later, right? But the first thing is, resiliency first. So you need to ensure the resiliency first and then look into the sustainability. So if you just look at the sustainability, the sustainable systems may not be resilient. And resilient systems may not be sustainable, but we want, that is the survival. We want our system to survive, resilient. And then let's think about, it's going to be there, and then let's see how we can make sustainable. So that's kind of a interesting aspect that we need to look at it. So just I gave you some simple example of it, and you can think about whatever you are doing. Think about, you can address, okay, even if you don't want to do any quantitative assessment, if you think this is too much, you don't know, but just, write in a descriptive terms, how sustainable, how resilient your design is. Write a discussion, sustainability aspects, sustainability resiliency aspects, have one section about that, and write those, in a qualitative terms. Okay, but I recommend you to get hold of this book to, get some initial information about initial concepts about sustainability and resiliency. So take home message is, okay, we are going to witness these climate impacts. We're going to see the impacts of this climate on our infrastructure. So we need to be prepared for that. In the long run, okay, we need to think about reducing the greenhouse gases, which is the main culprit of the climate change. So everything that we do, we need to think about carbon footprint, carbon footprint, carbon footprint, carbon footprint. Reduce the carbon footprint so that we can reduce the greenhouse gases and we can address the climate change issues. And then in the long run, we need to look at sustainability, broader environmental, economic, and social aspects. So that, you need to look at the climate adaptation and mitigation options so that, okay, we will be, addressing the short term as well as the long term issues. And then, think about frameworks. So look at the quantitative frameworks, because if you don't quantify it, the conclusions or, decisions may be very subjective and they could be wrong. So that's why quantitative framework is extremely important. Okay, quantify the resiliency, quantify the sustainability. The numbers may not be perfect numbers, but going through that process can help you, revise the things. So if somebody asks you, okay, you calculate the resiliency index, how much, how sure you are about the accuracy of those numbers, or sustainability metrics, how accurate you are. So there are a lot of assumptions or like some terms that may not be well defined. For example, social aspects are not well defined. Very it depends upon the surveys. So different people have different opinions about it, right? No two people are same. So everyone has their own opinion. So things are going to be very subtle. But going through the process will help you address the different issues that are important. So nature-based engineering solutions have potential to be resilient and sustainable. There are many case studies there where you can look at it. Okay, if I want to develop resilient and sustainable systems, what could be the best option? So anything you can exploit the nature or mimic the nature, then you're going to have better options. So I want to give you this contact information so that you can contact me if you have any questions, or you can go to my this lab websites. You can find those papers that I mentioned there in those slides. You can find them on these websites and you can download them and use them. I'm giving you WhatsApp, my number. You can contact me. I can add you to my WhatsApp groups, and then you can be in touch with me. Or I post the information related to publications, conferences, other things that could be potentially useful. So with that one, I want to thank you all. And if you have any questions, anything that we can discuss. So Nilima, I'm right on time, right?
Yeah. Thank you so much, sir. It's such a nice interactive sessions you handled for the last 5 days with the same energy and a lot to learn. Especially, I have a lot of things to read and learn.
Yeah.
So thank you so much, and I thank all the participants and speakers as well. Sir, we have some. I think I'll just open it. Uh, Nikhil, can you share the responses that we had from the participants? We can quickly take those points if there is anything to discuss, and after that we can close this event.
Okay, ma'am. Just give me a second.
Uh-huh.
Okay, people can unmute and ask questions, or
If
put,
there are any more questions, we can have it
you
here.
can put questions in the chat box. So let's utilize the time wisely. I know some people. I know the names of some people that I see. Can you guys show your video? Say hello to me. I don't. I didn't meet you in person, but I am familiar with the names that I see. Wait, one is forgot the names of people, but like I know the.
So, one question is there in chat box. Like
Yeah.
it seems quantifying RSI is still not developed at a level that can give exact idea how engineers can proceed. So how can we act to develop to calculate RSI or SRI more profoundly?
Yeah, I think what I mentioned is that so I think the methodology that we develop, it can be applied. I have a lot of other case studies where I demonstrate how it could be applied, how it will be helpful for decision making. But on the other hand, I want to mention other rating tool that's called Envision. So Envision is like a lead. Lead is for buildings. Envision is for other types of infrastructure. That's Institute for Infrastructure, and it's a part of ASCE. And then basically, you could do different considerations, different credits, and then you give the rating for each credit, and there is a guidance on how to give that rating, and that kind of system that has a lot of resiliency indicators and sustainability indicators, but they're not divided into distinct um categories. They're all mixed up, and you can look at those things and do the sustainability and resiliency assessment there. So and a lot of people, I mean, that those kind of frameworks are very good in if you're doing the regional projects. But if you are looking at a focused small projects, you need a framework like that, the one which I suggested. So what I would say is, the methods are there, but in terms of how you quantify those indicators, there could be a lot of uncertainty with that one. But doesn't matter. As I told you, this whole game is about, whole, effort is not to come up with the accurate number. Okay. So it's all about, following the methodology. Let's say, if you didn't follow those indicators, if you didn't think about those indicators, you would not have considered, right? So it's all about the process rather than the numbers. So, you know, you would never say that, okay, I have a very well established methodology that everybody can use it. So the methodology is there, but the process, if you go through when using any of these methodology, help you address the issues which you would not have addressed otherwise. So that's kind of the benefit of using these things, right? So the quantitative numbers at the end, you are talking in relative, right? So you have option 1, option 2, option 3. I'm not looking at, what is the exact SRI for this one, what is RSI for exactly for this one. So I'm not keen on that accuracy. Relatively, which one is better, right? So that's that you can achieve it. So that
Yes, sir. Thank you, sir.
so
Sir, like
I see
few
that.
questions are there. Yes, sir.
So
If any waste material to be used as sustainable material, what is the criteria to be set used as effective material? Okay.
so I mean, see, there are two things. One is the technical performance, right? Whether the material that you have used is can perform well for your application. That's one thing, in a environmentally and safe manner. That's one thing. Then when you want to apply it in the field, um, for the application point of view, whether it is sustainable or not, that's important. So waste material does not have any environmental emissions associated with that, right? So like unlike other materials, for example, if you want to use let's say instead of let's say I want to use gravel, so gravel requires you to for mining and processing and all those things that you have to consider in terms of environmental impacts. But you created a waste, uh, the waste is you would have dumped in a landfill, but you are using the waste for beneficial purpose. So all the impacts that you would have incurred uh, for acquiring a gravel, they're all eliminated. So you can offset all those impacts. So that's okay. But then in using it, right? Let's say you have a site and your waste material is way far, 200 kilometers or 100 kilometers, and then my other gravel is close to the site. So this is where the sustainability assessment comes into picture. So if you are transporting this waste material from this far away, the environmental emissions associated with the transport is going to be so bad compared, instead of that, you could use probably the natural material that, gravel that is available close to the site. So you need, don't say that if you use the waste materials, a lot of people use the term like, oh, I'm using the waste material, so it's a more sustainable project. But material composition, material comparison, it's fine. But when you are using for a particular project, for a particular application, then you really have to think about, is it really sustainable or not? So the transport distances have to be considered in the sustainability assessment. If things have to be transported for long distances, then the emissions of the transportation are going to be so bad that the material use is not going to be sustainable. So what parameters to be considered for measure the landfill sustainability? That's kind of a broad question. So overall landfill, right? So I think there are that's a really broad question. So for example, the like a presentation I think I gave yesterday. So which one is sustainable? Is conventional landfill is sustainable or bioreactor landfill is sustainable? So that kind of assessment can be made. In the landfill design itself, you could have alternative liner systems, alternative cover systems, alternative drainage layer designs. So each component design you can look into the sustainability. The other, if you want to take high level, is it landfilling is sustainable compared to other waste management options? So that could be at another level of sustainability. So you really need to look at which level you are looking at it. I have done a lot of different studies. You can find the papers on my my lab website. So we looked at the sustainability of the final covers, sustainability of the liner system, sustainability of the leachate collection drainage material. So you can look at the individual components of that. Okay.
So we can take some more questions from Google form that we have given them, provided them. I'm just going to share my screen so any of the speaker can take those questions.
So there is one more question, I think.
What is the way procedure to determine the carbon footprint for sustainable materials? So you can calculate the carbon footprint of any material. So so now you know what there's a lot of effort on the material that you have to look at what is the what is involved in preparing that material, making that material or having that material, right? So carbon footprint, you let's say, let's say
Mm.
I want to look at carbon footprint of concrete, right? So what are the resource materials that you need uh, from mining to while manufacturing the you need to have a cement, you need to have aggregates, and where are all those things coming from, and what it basically you need to look at the materials and energy that is needed for all the materials acquisition and preparation of the concrete. So you look at all those things and then uh, calculate it. So how much basically how you calculate is based on the energy that is needed for each of the tasks that involved, and what are the other materials that are involved. So each material has the carbon footprint. So you have different materials that are you're using in your prepared material, for example, concrete. So then you have to add all of those things. So steel has the same thing. Um, what happens is, when you do the life cycle assessment, you have databases. So people have actually, gone to the manufacturing plants and they measure all these emissions. So what is the energy that is needed? What are the different emissions, gases emissions. So in that you can find the databases for different materials. You can readily find those things that because people have already collected it. And if you are dealing with a new material that no information is available, then you can actually collect that information going to the actual manufacturing facility. So the best what we do is when we use the life cycle assessment, we use some software like SEMA Pro or other things, and then they have they have a linkage to the databases. The databases have materials and the machinery, and so they collected the information for each material, and they have listed that one. So when you are using for your project, when you're doing the assessment, I will say, okay, I have 100 cubic feet of concrete, I have so many tons of steel, and I have so much water and so much energy or so much so and so type equipment that I'm going to use for so much time. So consideration of all those things will give you the information. So the database is, you have an extensive database for European conditions, and you have reasonably, well, for North America. For developing countries, I think now the databases are being developed. I think for India also, in some sectors, they have advanced databases. But if you don't have a database, if you don't have the material or process in the database, then you have to, develop that data, and then you can put it in your analysis, right? So that's what I think, is a follow. There's another question also, like a database country like India is very hard. So that's the limitation, but you have to generate, even in the US, when we do some sustainability analysis for some materials in our research that are not in the database, we try to look at, any data that is available, and we try to create that data in that material data in the database. We add that one.
So we have some questions from the query form that we have given. I have just shared one of those.
These are for me, or these are for Ankit?
So it is like mixed of the speakers. Like anyone.
So this is actually for all, but there are questions for Ankit. I think
Yeah,
questions for you, sir.
Yeah, the first one is for Ankit, I think.
So this question related to slope stability. I think for plant roots, we can't, relate directly like soil nail, because there is one more major function, which I mentioned about hydrological response. I mean, it's a changes in soil water content and soil suction that is quite significant. I mean, as compared to soil nails. So that is one, and another are, I already mentioned some ecological processes that I think one needs to consider while considering plant roots, and also from a long-term perspective, because soil nails are like dead. You can't consider plant roots as dead. So that's one thing. Regarding the biochar, if you want to use biochar as a sustainable material in geotechnical applications, what are major focus of expert? When you talk about geotechnical application, it's still quite broad, I would say. You need to be very specific. First, for what is your main motive of using biochar? I mean, what properties of soil basic that you want to modify, okay, in that particular application? That is one thing you need to look at very carefully first. And then after that, you need to, once you understand your objective in that application, then you need to look at what kind of biochar you are looking for, what physiochemical properties of biochar you're looking for. So this is, the start that you need to know. And the third is then, there are several methods to carry this carbon footprint, but that depends on, on your application again. Which application you are taking, and then maybe you need to also carry life cycle, assessment for that LCA. But first thing, I think, is the first step itself is a challenging step. Where you want to, identify suitable biochar, also for suitable modification of soil properties. For certain application. Yeah. And I think the fourth one is, can biochar increase crop production? Generally reported in literature, they do have some positive influence on crop yield, and also to some extent macronutrients, but there are also many studies. We are currently actually writing a draft on negative impact, side effects of biochar. They have some issues if in case your biochar have some toxic elements, which we don't know before we add in the soil. There can be other way influence, and also biochar, if we add in excess amount, there could be increase in pH value beyond certain limit, which can also hinders plant growth. So I don't think we should generalize this notion that biochar increase crop production. Yeah, I think that's, I guess, from my side. Yeah.
Nikhil, can you zoom a little bit because the font is very less? Take it.
So we have like some small topics. I think we have comment on them.
Sir, there is one question. I think Venkatesh was asking about phytoremediation, if I am not wrong. So, Venkatesh, are you there? I can see him. Venkatesh, are you there? He was interested on phytoremediation.
Hello, madam.
I think you are interested, right? I think this is from your side, if I am not wrong.
Yes, madam. I am the one who is interested in phytoremediation.
Yeah, please. I think you asked a couple of questions also before, right?
Yes, ma'am. One is regarding what is the effect of pH on plants.
Ready, sir?
Hello.
Sir. Hello.
Okay, can you hear me now?
Yes, yes, sir.
Yeah.
Yes, sir.
So, the pH is a very important parameter to look at it. So different plants have a different tolerance to pH. So there are some plants that they can survive in a wide range of pH, and some they like, neutral, some acidic, some basic. So when you select the plant type, you need to, check those things. So when you plant in the environment in the pH conditions that they're not tolerable to the plants will not grow or will not survive. So you can look at the literature, and you can look at the plant type, and then you can look at the typical pH under which the soil pH that under which they can grow. So it varies from the plant to plant. Do you have any other questions?
So thank you, sir.
Yeah, thank you.
So, Venkatesh, are you doing PhD, right? I think on phytoremediation. Where are you working on?
Yes, madam.
So where are
Joined
you?
in Jain to Anantapuram.
Okay, you are working in Giant. Okay, sure.
Ma'am, I'm presently not working. I was joined there as a part-time student.
Okay,
Okay, ma'am.
sure. Okay. Thank you. So, sir, I think how can be a simulation of landfill happen?
I don't understand that question.
Question actually, yes.
Yeah, I don't know what is the simulation.
And what is the function of Geotechnical Society? Actually, I think
Yeah,
it
that's
is
for
also
you.
not clear, but I can say because of IGS.
Yeah, that's for you.
Of course, sir, it is my responsibility also as a National Executive Committee member. So there are two things. Right now, this year, IGS is celebrating 75 years, and we have almost 5,800 life members as of now, and many student members. So student membership is only for 1 year, but I generally suggest my students also to take life membership. Because there is a lot of information, and for students I can say what is a function means, like I'm maybe because there are a couple of people who are younger assistant professors also, so for them I can share. There is like first thing is like it is very very dynamic society where people from top firms, companies, practicing engineers, and all the faculty members from other IITs, NITs, everybody are part of this society. So we have an annual conference, which is a large gathering of around 700 people attend annually. I don't think any national society has this scale of event that do happen. And third thing, we do have a journal, Indian Geotechnical Journal, which is really doing very well. And this is also 50 years completed journal. It is a SCI journal. And then we also procured Plaxis 2D and 3D. This is only for academic purpose, and anybody can, member can, request for the, license, and you will be provided. So then we do have a newsletter. Quarterly, the newsletter is published where, like, whatever the job opportunities or any news related to any of activities. So a lot of information comes in the newsletters also. So in addition to that, if you're doing PhDs, and best PhD awards are there, best paper awards are there, there is a lot of scope. More than everything, it is actually our community where you can get to connect with very senior people, to your peer groups and younger faculty or younger people. And then a lot of information networking can happen. So I personally feel that I joined as a student member almost 20 years back when I was at IIT Delhi. And still I'm very active with the society, and I do have a lot of things to do with the society. So this is a big, and another advantage of taking membership this year is like 25% discount because celebrating the 75th year. So I hope I could clear whatever the function, I mean, I just mentioned benefits. Nikhil, can you go down if there are any? Biopolymers, I think, no query, nil. Okay, biokinetics. What is the question about? Okay, so I think we completed that also. Thank you so much for giving the response. Where do we need to request for Plaxis at IGS? See, you have to write, I think Pallavi, you have to, there is IGS admin email ID. Go to the IGS website, keep looking at the website. And if you're a member, I think you already might have received the email. If you didn't get it, just send an email to IGS admin, which is there on the website. Still, if you didn't get any help, then you can feel free to contact me on my WhatsApp. So thanks you everyone, sir. Special thanks to Reddy sir, and I really troubled him continuously since last 2 weeks. You have been so busy, talking to many of us. Sir, actually want to make maximum utilization of your time, and we want to take your guidance. I think Ashutosh also joined. Good evening, Ashutosh. So I also thank the speakers. So I also thank all other speakers, my colleague, Dr. Ashutosh. Ankit is a very good friend of mine. For everything, he'll, support me. And Supriya, Meghna, I'm very happy to host Meghna, who was my former student. And right now, DST Inspired faculty. He'll be joining soon at IIT Roper. Sir, this is just a 1 hour before news.
1 hour before news.
1 hour before. So she'll be joining soon at IIT Roper. And I think Supriya also joined.
Yes,
Good evening, Supriya.
Good evening,
So
everyone.
thank you so much for wonderful presentations. In this 5-day event, I really enjoyed all the presentations, but I wish that we should host all of you in IIT Indore.
Thank you so much.
Thank you so much, everyone. Thanks to my participants also.
Why don't we have everyone put on their
videos on
videos and take some screenshot?
Yes, sir. Yes. Good evening, sir.
Yeah, good evening.
Good evening, ma'am. Good evening, ma'am.
Good evening, sir. Let's have a good picture of everyone. At least one photograph of. If it was an in-person event, we would have had a lot of pictures.
Yes, true.
Let's give like a couple of minutes for people to put their makeup on and come. So see all the people, like, it's nice to see the faces, instead of just seeing the names on the screens. So see, good. Very good. See this, please show your video. So at least we should have one screen full of videos, not just the names. Venkatesh, where are you? Then you are there. Put your video on. Who is good in taking picture? Meghna, can you take the picture?
Yes, sir. I'm taking.
Do you see everybody on the screen?
Yeah.
Or you have some names that
Few names. Kritika, Venkatesh.
Kritika.
Yeah, sir.
Tell me when you are taking it.
So now?
You're taking it now? Okay.
Yeah, I'm taking continuously.
Okay. Let's see. All right. So tell me when you're done. Very good.
Yes, sir.
It's coming on the line. Just they're taking a little bit of time. Maybe just 1 more minute, we will see more faces. See, a lot of good people. So it's very bright faces. Excellent.
Thank you very much, Dr. Lady.
Hello.
Yeah. You
Sir,
got it? You got it, Meghna?
Yes, sir. It's done.
Yeah. So very good.
So thank you so much, everyone.
Yeah.
And I sincerely thank our international office for providing, this platform of Vajra and SCRB, basically, who funded to host Reddy sir. and also IGS. I think, I got a huge support from President Anil, who is highly dynamic, and then APC, Honorary Secretary, for providing the Zoom platform, everything, and all other my colleagues at IT Indore, and especially my students, Mr. Kunal, who is not here, who is in Italy now, and next Nikhil Pandey, who really helped in organizing this 5-day event. But I wish that we should all meet on offline at IT Indore. I welcome you whenever you are coming to Indore, traveling to Indore. Please visit us. I'll be very happy to host you. And thank you so much. All the very best for the students. And let's be in touch. I already shared our details of our lab. So in the Facebook, we are very active. I keep posting our details and updates. So we'll be happy to, and if there are any undergraduate students, we have a very active internship programs at IT Indore. So if you're a faculty member, so there is a web page, you can contact me on WhatsApp and I can guide them. So we are having offline internships at present. So that's all from my side. Thank you so much and have a great evening.
Yeah, thanks everyone.
Thank you.
Thank you,
Vikram.
thank you, sir.
Thank you very much,
Thank
sir.
you.
Thank you very much, ma'am.
Thank you very much.
Thank you very much, madam. Saran.
So Supriya, your student is done with PhD defense?
No, sir. I think in next week or so it will be done. Next week we are planning. It has not yet done. I received the comments only. That's why I emailed you. I received the comments last week. So thank you.
Actually, there were participants from Keller. Can you kindly introduce, because I have a lot of friends in Keller.
Yes. Good evening to all of you.
Good evening.
Good evening.
My name is Kamaraj. I am working with Keller more than 20 years. Beside me, Mr. Rafiq and Mr. Ilango. He is a previous student of IIT. I hope Ilango can. Before handing over to Mr. Ilango, I would like to express the thanks and gratitude to all the doctors and lady legends in this program. I saw a lot of them are presented nicely about the sustainability. I am the HSEQ manager, but I was much interested to learn something about the sustainability where I am working to implement such things. It was very useful for me. I am going to implement it. Mr. Yelambo will give some good words about this program. He is the general manager. Already he knows. You may know him. Okay. Muted.
Good evening, all of you.
Good evening.
Thank you for the wonderful session. I think then as I am a IGS member, I invited all my colleagues to join. I think I had a good feedback from us. It is echoing. As a Keller, we are also working on the sustainability. That's what it was very useful session.
Sorry, give me a moment.
You had some projects also in India, right? Sometime back, Mr. Ramdas and Hare Krishna, they visited my office. Anyways.
Yeah, sorry.
So thank you so much.
Yeah, I think Professor Nilima, I called you when I was in IIT Indore. Indore, I came for this NRI conference. Then I couldn't meet
Yeah,
you.
I think you came with Mr. Ramdas, I guess, right?
No, I came for NRI conference. So
okay.
I only called by phone, but we couldn't meet actually. But it's good that this good platform, everybody is here. We could join from the other side. We are in the same page where we are working on sustainability. We'll be able to get some more information in person. Thank you very much for the session.
Thank you. Thank you so much.
Thank you so much for joining. So it was a great, because if we could have known that, you could also present what you are doing in the industry, that could have been brought another different flavor also to the workshop. Anyway, next time I'll try to plan it. Thank you so much. We close this event.
Yeah. Thanks, everyone.
Thank you. So let's be in touch, and all the very best to students, participants especially. Thank you so much for attending. And it was a very active session. I sincerely express my thanks to Reddy sir again and all the teachers. Thank you.
Thank you so much, ma'am.
Thank you, Supriya.
Thank you, ma'am.
Thank you.
Shall we end the meeting from our end?
Yeah, sure. Thank you so much.
Bye bye.
Thanks,
Thank you,
everyone.
ma'am. Bye.
Thank you, everyone. Bye.
Nice to meet
Bye.
you.
Bye.
Bye, Meghna.
Bye.
Congratulations.
Bye, everyone.